Welcome to The Explainer. Today, we're cracking open some of the universe's most captivating cold cases. We're talking about massive, world-altering discoveries that made international headlines, rewrote the textbooks, and then, well, quite literally just vanished. I am so excited to guide you through this, because honestly, there is just nothing quite as thrilling as a good cosmic mystery.
It's a serious question, though. Can a confirmed planet simply disappear? I mean, you'd think that a giant sphere of rock or gas, verified by top astronomers and some of the most powerful telescopes in human history, would be, pretty hard to misplace. But, as you're about to see, our universe is absolutely full of optical illusions, mathematical ghosts, and catastrophic events that can trick even the brightest minds on Earth. Okay, let's dive right into this. Case File 1, the Ghost of Vulcan. So, back in the 19th century, which is where this first mystery begins, there was this brilliant French astronomer named Urbain Le Verrier. This is the very same guy who successfully predicted the existence of Neptune, by the way. Anyway, he noticed an anomaly. Mercury's orbit was wobbling. It was shifting just slightly in a way that totally violated Newtonian physics. So Le Verrier confidently calculated that this wobble had to be caused by the gravitational tug of a hidden inner planet orbiting right between Mercury and the Sun, and he named this unseen world Vulcan. Now, this prediction kicked off an absolute frenzy. Le Verrier made his calculations around 1845, and for the next several decades, astronomers were just completely obsessed. They literally traveled the globe to stare at solar eclipses, desperately hunting for Vulcan's silhouette against the sun. And people were so convinced it was there that some observers even claimed they could see Vulcan's red, scorching rocky surface. But despite all these supposed sightings, the math never completely added up, and definitive proof just remained totally elusive until 1915.
Because here is the crazy twist. Vulcan never existed at all. In 1915, Albert Einstein published his theory of general relativity. He proved that gravity isn't just a simple pulling force, it's the actual curvature of space-time caused by massive objects like our sun. So Mercury's wobbly orbit wasn't being tugged by some phantom planet. It was simply following the curved space created by the sun's immense mass. And just like that, Einstein beautifully solved a 70-year-old mystery, and the planet Vulcan was wiped from our solar system forever.
All right, let's fast forward a bit. Case File 2, the Disappearing Act of Fomalhaut B. From a historical misstep, let's transition to a modern, active investigation. In 2008, astronomers Paul Callis and James Graham made a really triumphant announcement. Using data captured by the Hubble Space Telescope in 2004 and 2006, they had directly imaged an exoplanet orbiting the star Fomalhaut. They called it Fomalhaut B. And man, it was hailed as a monumental breakthrough, a directly imaged gas giant. But as the years went on, subsequent observations started noticing something kind of strange. The object wasn't glowing with infrared heat like a normal planet should, and even weirder, it was fading.
Well, in 2020, researchers Andres Gaspar and George Rica analyzed the archival Hubble data and realized Fomalhaut B wasn't actually a planet at all. It was the aftermath of a massive cosmic hit-and-run. Two huge icy planetesimals, each about 125 miles wide, completely smashed into each other. That incredible impact created a dense, brightly reflecting dust cloud that looked exactly like a planet from Earth. But as that cloud expanded out into space, it faded, eventually dropping completely below Hubble's detection limit by 2014.
I mean, just think about the sheer rarity of what we accidentally witnessed here. We didn't find a planet. We caught the exact moment a planetary body was annihilated. As astronomer George Rica perfectly summarized in the source material, this is a blueprint of how planets destroy each other. So Fomalhaut B was officially removed from NASA's exoplanet archive. It was a ghost of a world that turned out to be a beautifully violent cloud of dust.
Moving right along. Case File 3, the Great Exomoon Debate.
Heading further out into the galaxy, we arrive at an ongoing investigation. And here we have a classic scientific standoff. On one side, you've got David Kipping's team at Columbia University. They analyzed light curves, those tiny dips in starlight when an object passes in front of a star, and found evidence they believe points to the very first exomoons. But on the exact opposite side, researchers from the Max Planck Institute used a newly developed computer algorithm called Pandora to re-examine that exact same data. Their conclusion? They argue the data is much better explained by a planet-only model. Basically, no moons required.
At the absolute core of this disagreement is a process called detrending. Detecting an exomoon is incredibly difficult because the amount of light they block out is just astonishingly faint. To even find them, scientists have to clean up the messy telescope data using these detrending algorithms. But here's the catch. The specific algorithm you choose can radically alter your results. It can literally be the difference between seeing a groundbreaking new moon or seeing absolutely nothing at all.
So the crucial point here is how these teams view each other's data processing. Kipping's team forcefully defended their exomoon candidates, pointing out what they see as a major flaw in the skeptics' approach. They argued that the Max Planck team's alternative Pandora algorithm actually increased the noise in the data by 20% and discarded 11% of perfectly useful data. And by doing that, they effectively erased the exomoon's delicate signature. This debate is still raging on, and it really shows us just how razor-thin the line is between a historic discovery and an algorithmic artifact. Okay, let's bring it back closer to home for our final case. Case File 4, the hunt for Planet 9.
This right here is the biggest missing persons case in our own solar system today. Let's look at the clues that kicked off this modern gold rush. Back in 2016, Caltech astronomers Konstantin Batygin and Michael Brown published a total bombshell of a paper. They observed that the orbits of over 96 extreme trans-Neptunian objects, these are icy rocks way out beyond Neptune, were clustered together. They were pointing in the exact same direction instead of scattering randomly like they should. According to Batygin and Brown, conventional models of the solar system just cannot explain this. The tidiest explanation? An unseen, massive planet, maybe 5 to 10 times the mass of Earth, just lurking out there in the dark and pulling these rocks into alignment.
Now, there is a massive divide in today's astronomical community over this. The believers argue that Planet 9 is the only clean, single solution that ties all these strange orbital anomalies together. But the skeptics, like astronomer Samantha Lawler, for instance, push back hard. They argue that this clustering is just observational bias, basically saying we're only seeing them cluster because that happens to be where our telescopes are looking. Others even suggest we don't need a new planet at all, but rather a tweak to our understanding of physics, something like modified Newtonian dynamics.
For about a decade now, Planet 9 has been a mathematical ghost, very much like Vulcan once was. But that is about to change. Coming online in Chile in 2025 is the Vera C. Rubin Observatory. This thing is the largest digital camera ever built. Its decade-long survey will comprehensively map the outer solar system. If Planet 9 is actually out there, this observatory is the ultimate tool that will finally pull it out of the darkness and into the light. And if it doesn't, well, we might have to rethink our solar system all over again.
Which brings us to our conclusion, the verdict. Science as the ultimate truth seeker.
As we close out these case files, it is really vital to look at the big picture. When a planet vanishes or a moon is debated away, it might feel like a failure, but it's actually exactly the opposite. Let's review our cases one last time. Vulcan was disproven, yeah, but its death gave us Einstein's General Relativity, which fundamentally changed physics. Fomalhaut B vanished, but it gave us our very first direct look at a planetary collision. The exomoon debate remains unconfirmed, but it's forcing us to build better, more precise algorithms. And Planet 9? It sits in the hypothetical column, but it's driving the creation of revolutionary new observatories. Every single one of these mysteries, whether they end up solved or unsolved, pushes our human understanding forward.
Which leaves us with a lingering thought I want you to carry with you. If a confirmed planet can turn out to be nothing more than a cloud of dust, and if a quirk in Mercury's orbit can rewrite the very laws of gravity, what other truths of our universe are you and I accepting today that are just waiting to be completely rewritten tomorrow? Keep questioning, keep looking up, and thank you so much for joining me for this explainer.